In this session, we're going to introduce graphs and networks, their basic concepts, and their representations. So what is a network or graph? A network or graph usually treated like synonyms. A graph G is represented by a set of vertices, V, or also called nodes for some literature, and a set of edges, E, or some people call a set of links. Okay. E actually is a subset of V cross product with V. Then N is the number of vertices, or also called order of G. M is the number of edges, also called the size of G. The multi-edge means if there exists more than one edge linking between the two vertices, for example, 1, 2, if there were more than one edge, we call this as a multi-edge graph. Okay. And also the loop means edge connects a vertex to itself. Usually we call this as a self loop. For example, if you get a 1, you get another edge also connected to 1 directly, that's a self loop. For simple network, we will not consider self-edges or multi-edges. Then if we want to represent this simple network, we represent it as an adjacency matrix. If I and j is 1, simply says there's an edge connecting between vertex I and a j. Okay. Then otherwise it's a 0. Okay. Directed graph simply says the edge may have directions, like tail, point to head. In that case, if the adjacency matrix A sub ij equals 1, means there's an edge from j to I. It's directed. Otherwise, it's 0 if there's no such a directed edge. Okay. Sometimes the graph may not just a 1 or 0, they may have certain weights associated with every edge. Weight W sub ij, usually it's a real number, is associated with each vertex, each edge V I sub ij, then this graph is a weighted graph. Then we see how to define the vertex degrees. Suppose we get network G consists of a set of vertices and edges. For undirected network, essentially there's no direction like this graph, then the degree of a vertex is defined as how many edges from the other ones going down here. Going in and out is just the same because it's undirected. So, for example, okay, we give it A. Obviously, the number of edges connecting to A is 4. That's why the degree is 4. Similarly, the degree of H is 2. Then we look at directed network. Directed network, the in degree is how many edges pointing to these V sub I. Okay. For example, if you look at the in degree of A, you can see there are 3 edges pointing to A. That's why in degree of A is 3. Then in degree of B is 2, obviously. Our degree just reverse to look at how many edges actually going out of it. Okay. From V sub I. Okay. Then if you look at the A's outgoing edges, you will find only 1, but B's outgoing edge you still can find 2. So that's the basic concepts of vertex and the degrees.